The following is an example of a calculation of the pH during a strong acid, strong base titration. Calculate the pH when 49 mL and 51 mL of 0.100 molar of sodium hydroxide solution have been added to 50 mL of 0.100 molar of HCl solution. So as we can see, sodium hydroxide here is a strong base, and HCl also is a strong acid. So the reaction that we are looking here is HCl plus the sodium hydroxide neutralizing and producing H2O plus sodium chloride. Now, because we are doing that titration with a strong acid and strong base, both of them are dissociated at the beginning of the reaction. And when we have the products, we can see here that we have water, but also sodium chloride. And sodium chloride is an ionic compound, so it's dissociated also in water. So that means that the ions of sodium and the ions of chloride, they are spectators for this reaction. So we really have, the reaction is H positive plus OH producing negative, producing water. This is the neutralization reaction that we have when we are doing the titration of sodium hydroxide with HCl. We need to calculate the pH in 2 points during this titration. One of them is the point A, when we add 49 mL of sodium hydroxide to 50 mL of the HCl. We can see that both concentration here of sodium hydroxide and HCl are the same, and also this reaction is 1-to-1 in the stoichiometry. So that means that if we have 50 mL of HCl and 49 mL of sodium hydroxide, those moles of the 49 mL has been neutralized by the moles of HCl, but we have an excess of HCl at that point. Okay, so we need to determine the pH, and the pH is going to be equal to minus log the concentration of H3O plus. So we need to look for this concentration after that volume has been added. So to do this, we need to calculate the moles of H positive, and to do this, we have the volume that we add is 50 mL, so it's 0.050 liters of solution, multiplied by the concentration of HCl, so that is 0.100 moles over 1 liter of solution. And by this we can cancel the units of liter of solution, and this will be equal to 5.00 times 10 power of minus 3. These are the moles of H positive that we add. The moles of OH will be the volume that we add of sodium hydroxide, that it was 49 mL, so this is 0.049 liters of solution, the solution that we add of sodium hydroxide, and the concentration for that was 0.100 moles. This one was of OH negative, this one is H positive, divided by 1 liter of solution. Here also we can cancel the units of the liters of solution, and we're going to have here 4.90 times 10 minus 3 moles of OH. So as difference that we're not going to use, we are going to use now the Rice table, but instead of using the units of molarity for this table, we're going to use the units of moles. So the initial, here we have initial change and equilibrium, the concentration basically of the proton and the concentration of hydroxide and water. So before the reaction, we have of acid of H positive 5.00 times 10 minus 3 moles. And for OH, we have 4.90 times 10 power of minus 3 moles, and water is basically constant. Now, the change. To determine the change, we need to look at our limiting reactant. Okay, so here we have two amounts of moles. We have here 5 moles and we have here 4.9. So that means that hydroxide at this point is our limiting reactant. So all the moles of hydroxide are consumed, okay, by the moles of the sample of H positive. So that means that the change is due to OH, so the change will be minus 4.90 times 10 power of minus 3 moles. And the change for H positive is going to be the same because it's the same amount of moles that react of hydroxide with the product, with the H positive. So it will be minus 4.90 times 10 power of minus 3 moles. Okay, so now at equilibrium, that means that there are 0 moles of OH and there are 0.10 moles, times, this will be times 10 power of minus 3 moles of H positive. Now remember that we need to look for the concentration of H positive or H3O, okay? And this will be equal to the moles of H positive, that will be 0.10 times 10 power of minus 3 moles of H positive divided by the volume of the solution. But remember that we add 50 mils of HCl and 49 mils of sodium hydroxide. So our total volume now is 99 mils. So this is the volume that we need to add in this calculation to determine the concentration of OH. So changing this to the units of liter, we will have 0.099 liters. And this now will be equal to 1.0 times 10 power of minus 3 molar. So this is the concentration of H positive. So now the pH will be equal to the minus log of 1.0 times 10 power of minus 3, and this will be equal to 3.00. So the pH at this point, where we are doing a titration of a sample of HCl with sodium hydroxide, when the sample is 50 mils, and we had add 49 mils of the sodium hydroxide, the pH at that point is 3.0. Now, for the part B, we need to determine the pH when we add 51 mils of sodium hydroxide, 0.100 molar of sodium hydroxide, and we have the sample of 50 mils of 0.100 molar of HCl. Okay, so to this we need to look for again for the moles of each one. So let's look for the moles here. This will be the volume, 0.051, in this case liters, times 0.100 moles of OH divided by 1 liter. Remember that because the sodium hydroxide is an ionic compound, it could be dissociated. So the concentration of sodium hydroxide is the same concentration as OH. So that's why we substitute sometimes you see sodium hydroxide or OH. So now we cancel the units of liters, and this will be equal to 5.1 times 10 power of minus 3 moles of OH. For the HCl, we said that before, so it's 0.050 liters times 0.100 moles of H positive divided by 1 liter. This is the concentration, okay, of HCl, 0.1, and this will be equal to 5.0 times 10 power of minus 3 moles of H positive. So now, here is basically the same concept as the rice table. So before the reaction, we have 5.0 times 10 power of minus 3 moles of H positive, and we have 5.1 times 10 power of minus 3 moles of OH, and the water basically doesn't change. Now, which of this is the limiting reactant? Which one has the less number of moles? Now, the reactant limit is H positive. So we're going to consume all of the moles of H positive. All the moles of the sample has been consumed. So now the change will be due to the moles of H positive, because it's a limiting reactant. Moles, and also for this one it will be minus 5.0 moles, time 10 power of minus 3 moles. So after the reaction, this has been cancelled, so we have 0 of H positive, and we have 0.10 times 10 power of minus 3 moles of OH. Now we need to determine the pH, but the moles that we have are the moles of OH. So we can calculate from this concentration the pOH and then the pH. So how can we do that? So let's work first, determine the concentration here. The concentration of OH minus, that will be equal to the moles of OH, 0.1 times 10 power of minus 3 moles of OH, and we divide this by the total volume. But remember that we have in case B 50 milliliters from the HCl and 51 milliliters from NaOH, sodium hydroxide. So this will be equal to 10 ml of solution. So we change that to liters, and this will be equal to 0.101 liter. And this will be equal to 1.0 times 10 minus 3 moles of OH. So now we can use this value to determine the value of pOH. That this will be equal to minus log of 1.0 times 10 power of minus 3. So the pOH is equal to 3.0, and the pH will be equal to 14 minus the pOH. So this will be equal to 14 minus 3. So the pH will be equal to 11.0.